Alright, so we're going to go through some examples now. We're going straight to composite shapes. We're not going to do individual shapes because you should already know how to do that from year 8. So this composite shape here involves two rectangles. So you can split this by going across or you can split it by going up. That's when we get to the area. But first we're finding the perimeter. So the perimeter is the length all the way around the outside, so we need every side. Now we've got two missing sides here. So if we want to find this missing side, which is horizontal, you look for the other horizontal sides in the diagram. That's 33 and this is 15. So that would be 33 take away 15, which gives you 18 for that side. Okay, so we can put an 18 there now. Just mark it on in red. Now this other one, I might just use a blue pen for this one. So this one here we don't know, and that's vertical. So then we've got all the other vertical sides in the diagram. So this is 28 and this is 15. So that one will be 28 take away 15, which will leave 13 for that side. So we're going to write 13 centimetres on that side. And now for the perimeter, we're going to add them all up. Now, so you don't leave any out, just start at one point, one corner, one vertex, and go around the shape either clockwise or anti-clockwise, whichever way you want, but that way you don't leave any out. Okay, so I'm just going to start here in the top right corner, and I'm going to go around this way, clockwise. So I've got 28 plus 15 plus 13 plus 18 plus 15 plus 33. And that's all of them. I haven't left any out if I go around like that. Alright, so now we just add them up on the calculator and see what we get. And we end up with 122. And don't forget to put your units on the end, centimetres. Okay, now we're doing the area. So the area is the space inside, and as I said before, we have two rectangles. So we can go across or up, doesn't matter. Alright, so I might just go across, put a dotted line in. I'm going to do that top rectangle first and call it area 1. So area 1 is the length times the breadth, which is 33 times 15. And you can work that out on your calculator as we're going. And we get 495. Okay, don't worry about the units yet because we haven't finished. And then this second area down here, I'm going to call A2. So we've got area 2 equals the length times the breadth. And in this case, we've got 13 times 15 for our length times our breadth. And we can work that out on the calculator as well. And we get 195. And then we're going to be totalling them up. So we have 495 plus 195. And we'll end up with 690. And we're writing centimetres squared on the end. Okay, number 2. Again, we're doing perimeter and area. So looking at the perimeter first, we're doing the total length around the outside and we need every side length. Now in this one, we don't have that side there, so we need to find it. So sloping sides, remember, probably going to be your hypotenuse on a right angle triangle. So if we just draw up a dotted line there so we can see that triangle that's there, and then that is your hypotenuse, we might mark it as a C. And let's see what else we know. Well, that side there is going to be the same as that one. So that's 9. So just write it in with red pen. So that's 9 centimetres. And this one down here, from here to here, well, you've got the whole thing is 20. And then this is 8. So that will be 20 take away 8, which is 12. Okay, so we'll write that one on as well. And then we're going to use Pythagoras' theorem to find this side length. Okay, so to do this, I probably don't have a lot of room down here. You may have room on the right-hand side of your column. I'm just going to write it up here for the moment, but it's probably better if you write it down here on the right. Okay, so we're doing c squared equals a squared plus b squared. And if we put the 9 and the 12 in, I'm just trying to work this out in my head. Just double check it, just to make sure we're not making a mistake with it. Yep, 225, if we square root it, we're going to get 15. Because I knew that this was going to be a Pythagorean triad, but this just proved it. Alright, so the answer for that is 15 for that side, and you can now write it in. Okay, so if any of you spotted it, there is a Pythagorean triad going on there. So 3, 4, 5, I'll just get a different colour just to mark this on. So the 3, 4, 5 triad, if you multiply them all by 3, will give you 9, 12, 15. And we have the 9 and the 12. 15 was our missing side. So for those of you smart enough to spot the triad, you can use that. Alright, now we're coming down to adding up our sides for our perimeter. I'm starting in the top left corner and I'm going around this direction. So we have 8 plus 15 plus, now when you get to here, it's the whole side, so we're doing 20, plus 9, and you've got the 4 sides of the shape added up. So if we add these up, I'm trying to do this in my head, we've got 23, 43, and 9, 52 centimetres for your answer. Alright, now we're doing our area. So I'm going to call this one area 1, and this one area 2. So our rectangle is area 1. Length by breadth is 9 by 8. So you get 72 for that first one. I want everybody writing there, all the working down for these, no excuses. Formula, sub in, and answer. I want the formulas there. Okay, so the next one we're doing is the triangle, which is this bit. So half base by height. So our base and our height are 12 and 9. So it's half times 12 times 9, which gives you 54. And now we're going to add our two areas together. So we have 72 plus 54, and you'll end up with 126 centimetres squared for area. All right, looking at number 3. So we'll start with our perimeter. There's a few missing sides. This one, they've told you, is equal to that one, so we know that's going to be 10. Now we need to find this one. All right, so it's part of a right-angled triangle. Let's draw in the rest of it. So we have a 24 here. This side is the same as the opposite side of that rectangle. So that's a 30 there. And we're trying to find that. So let's see how many of you can see if this is a triad or not. So we've got a short side we're looking for here. The hypotenuse we know. So if we have a think about it, let's have a look. We have something 24, 30. Let's see if that works out to be anything. They're all multiple. Those two are multiples of 2. They're multiples of 3. Both of them. You've got to look for things they're both multiples of. And they're multiples of 6. 6 is the highest one that I can think of that goes into both of them. So if we divide by 6 and divide by 6, that will give me a 4 and that will give me a 5. And I think you know what number goes in there. It's a 3. Now remember I divided by 6 here, didn't I, to get these? So what am I dividing by 6 to get the 3? 18. That's my missing number. It's going to be 18. Now for those of you who couldn't do it with the triads, that's okay. They're not all going to be triads anyway. Just go through your Pythagoras' theorem, put in the numbers that you did have, And just keep going from there, and you'll still end up with the answer of 18 if you continue from there. Okay, so we're finding our perimeter. I'm going to start here in this left corner here and go around. So we've got 24 plus 18. Perimeter, remember, we're going all the way around the outside of the shape, plus 10, plus 30, plus 10. I don't want to see anybody adding on that 30 in the middle there. We're going around the outside for perimeter. All right, now we're going to total these up. And it should be 92 centimetres. I'm sure you'll let me know if I've made a mistake. All right, now we're doing area. So we're going to do our area 1 being our rectangle, and area 2 will be our triangle. So for our rectangle, we do know the length and the breadth are 30 and 10. So 30 times 10 gives you 300. Now the triangle, area 2 is a half base by height. So be careful with this. You want the base and the perpendicular height. You need to be looking for the right angle. There it is. So if I call this the base, the perpendicular height comes off the base at right angles, so that's your perpendicular height. Or you might call that your base, and then coming off that base at right angles is that 24. So either way, they are your base and your perpendicular height. So let's put them in. Okay, let's just quickly work this out. And we end up with 216. And now we can total our two areas up. So we've got 300 plus 216, which is 516 centimetres squared. Okay, looking at number 4. So number 4, we're looking for the area of the shaded arrow. It's this big arrow here in the middle of the shape. So we're finding the area of that. Now, we could try and split this thing up into a triangle, and then if we're doing across here a rectangle, you could do it that way. I'm going to do this using subtraction, just because we haven't done one with subtraction yet. So let's see, if we do, and the way I normally do it is to use some words so you know what you're actually doing, and the person marking it can follow what you're doing. So I'm going to do the big rectangle area first. So I'm going to write big rectangle. Okay, so let's find the area of that. So it's length by breadth for a rectangle. The length of that rectangle will be 3 plus 3, so that's 6. The breadth will be 2 plus 1, which is 3. So we have 18 for our area of the big rectangle. Now, these are the bits we don't want, right? We're going to get rid of that. We're going to call that area 1, that little piece in there. And this piece over here is identical to it. Okay, so we've got another area 1, if you like. They're going to be identical. Now, down the bottom here, we have a little rectangle that's going to be cut out. And this little rectangle over here is also identical to it. So there's only really 2 areas we're trying to calculate here. So let's have a look. So we've got area 1, which is a triangle, half base by height. All right, now I'll just move this over so you can see what we're doing. Okay, there's a fair bit more to go, so I'll just move it further over for the next one. All right, so let's have a look. All right, so in this one here, we're now finding the area of this little rectangle up the top here. Sorry, triangle up the top. So the base of that triangle is 3 and the height is 2. I'm going to put that in, half times 3 times 2, and you'll get an answer of 3. We're going to work out area 2, which is a rectangle, length by breadth. The length of it, we'll come back to that in a minute. Let's just call the length 1 because we know that. All right, now this length here if you look at the diagram, they have told you that these three sides here are equal. Okay, so the whole length up here is 6 when you add the 3 and the 3. So down here, if we have 6 all the way, and then we split it into 3 equal bits, 6 divided by 3, each of those bits is 2 centimetres. So you can write 2 centimetres in on that part there. So now we've got 1 times 2 for that rectangle, which equals 2. So now, to get our required area for our arrow, we are going to have the big rectangle, which is 18. We're going to take away area 1. We're going to cut that piece out and throw it away. This is identical, so it's another 3 gone. Area 2 was 2. And here's another area 2, which is also identical. So you've got to subtract all these little pieces, cut them out and throw them away to leave the arrow on its own. All right, so we're going to end up with 8 centimetres squared for your final answer. All right, now this one here, right, this sort of thing happens in real life. We need to know how to do these. So we're finding the area of a block of land. All right, so the block of land looks like this. If you live at the end of a cul-de-sac or something, any of you watching the block might see if somebody's at the end of the cul-de-sac, that they can't be rectangular blocks of land. They have to actually shape around a curve. So there will be some odd shapes like this. All right, so to find the area of the block of land, we're just doing area, so we're not worried about perimeter this time. Get your red pen and draw in that line at a right angle. We're splitting it into 2 shapes. Area 1 for the rectangle, area 2 for the triangle. So in the rectangle, that's pretty easy. We've got a length of 800 and a breadth of 500. So let's put those in. And if you work that out on your calculator, you'll end up with that. Now our triangle, so we need these 2 sides here. That one and that one. This one's easy because it's the same as that, so it's 500. Write it in red. And this piece here, remember this is all 1300, and this bit from here to here is 800. So we're going to do 1300 minus 800, and that will leave you with 500 for that side. Let's write it in. So both of those sides for the triangle, the base and the perpendicular height, are both 500. So let's write that in. Okay, and then you're going to your calculator to work this out. And I think that's right. I'm trying to do it in my head. Yep, that should be right. Okay, so now we're totalling up our areas. We've got, what is that? 400,000. Let's move this away. Right, 400,000 plus 125,000 will give you 525,000. Now, it's in metres squared for area. Now, in part 2 of this, they're wanting you to get that answer and change it into other units. So in the first one, we're changing it to metres squared. So at this stage, we have 525,000 metres squared, and we're converting it to kilometres squared. Now, don't muck this up, all right? A lot of boys will make mistakes on this, so think about it. From metres to kilometres, you're going to a bigger unit. So we're dividing. Now your prefix is kilo, so we're dividing by 1,000. And a lot of people, that's what they do and they get it wrong. When you're converting square units, if that unit is squared and that unit is squared, the 1,000 has to be squared as well. So you're putting into your calculator 525,000 divided by 1,000 squared. If you do that, you're going to get this answer. Okay? So be very, very careful with that. All right? Now let's look at the next one. We're converting to hectares. So we'll start with the answer we had before. And we need to convert to hectares. Now the abbreviation for hectares is HA. If you can't remember it, just write the word hectares. Now for this one, we're not doing what we did up here because the two units don't have squared on them. Okay, so you're thinking, are you going smaller or bigger? Well, a hectare is a really big piece of land, so we are going bigger. And we are dividing by, now you need to know how many metres squared are in a hectare. So this needs to be known. If you don't know it, learn it. 1 hectare equals 10,000 metres squared. The way I remember it, it's a 100 metre track for a sprint times by a 100 metre track, and that is your square, that is your hectare. That's how big it is. 100 times 100, if you do that on your calculator, is 10,000. So it's a good way to remember it if you forget. So we're going to do this divided by 10,000, and if you do that, you will end up with 52.5 hectares. And that's the end of the examples today, so now you can just do some practice on this work.